Welcome to Session 2 in the UC Migration webinar series. I'm Rich Steves, Web Editor at TMC.
And I'm Alan Percy, the Senior Director of Marketing at Audio Codes.
So Alan, what is this session about?
Yes, so session number 2 is about emergency services in E911. What we're going to be covering is the process of implementing 911 emergency services with Microsoft Lync, which is obviously very important for businesses to make sure their employees are safe and be able to handle compliance with local regulations relative to emergency services.
Can you tell us a little bit about our presenters?
Sure, we've got two great presenters for today. We start with Pascal Menendez. Pascal is a senior program manager at Microsoft, and he's worked closely on the survivable branch appliances in E911. He's played a key role in a number of network technology companies, bringing over 25 years of experience in internetworking technologies. He's got a number of credentials. He's worked on a number of industry forums and standards bodies, and he's a subject matter for Microsoft on this particular topic. In addition to that, too, we're going to be joined by Chris Sheridan. He's a solution architect for Sentry, and he's also a TSP for Microsoft. He's been a network engineer and technical trainer for 15 years, specializing in Microsoft solutions. He currently specializes in unified communications and collaboration with Microsoft Exchange, SharePoint, Lync, and et cetera, supporting technologies across the board. And again, a great presenter, and glad to have him as part of today's session.
Absolutely. Let's hear what they have to say.
Great.
So first, it's important to understand how imperative, that quick and reliable access to emergency services is for people in the workplace. During a study done by the Federal Communications Commission in 2008, Americans made over 240 million calls to 911. Roughly 2/3 were made to wireline, landline, or office telephones, or from wireline, landline, or office telephones. In Washington, D.C., the first responders received 1.8 million 911 calls per year. Los Angeles had 5 million per year, and Baltimore 1.7 million. So it really does seem that 911 is the most popular number you hope you never have to call. But of course, it's easy to assume you would dial 911 when you witness a car accident, but workplace accidents do happen. Medical emergencies, spills, even fires occur in the workplace, and of course they require quick access to first responders via the E911 system. However, enterprises have got some really unique challenges when it comes to dealing with E911. First, I think it's important for businesses to understand, the local regulations and laws that might affect their E911 implementations. And then businesses, frankly, they need to decide what steps or policies they'd like to implement above and beyond the regulations. Larger facilities and campuses have to deal with location information, helping the first responders locate the 911 caller or the emergency. And there are a lot of choices between different methods to deliver 911 access, and we're going to talk about two of them today: the next generation 911 or enhanced 911. And then lastly, then there's the issue of the mobile and branch office employees, which is what kind of facilities do you implement to service their needs, if any. And to help you answer your questions, we've invited Pascal to join us here. He's going to share some background and best practices on the location services of Microsoft. And Pascal, I'm going to ask you to take it from here.
Thank you, Alan. Well, I appreciate the many folks on this webinar, and so I will cover off basically how Lync 2010 implements 911, and I'll cover two models, basically the ELIN model, which is traditionally what's being used in the TDM networks today, and this called Next Generation 911, what's the future of where emergency service is going to, and we actually support that today in Lync also. So with that, let me take over the slides here, and I got to basically disclose our legal disclaimer, and as you can see, information here is as is information. And any feedback you give, you don't have to give feedback. Any feedback you do give could relate back into our products and so on. So this is our legal disclaimer, and you can read that. So moving on, let's start with 911 and E911 background. Obviously, Alan gave a great overview of that, but basically, obviously, 911 is very critical for emergency services, both in the United States, Canada, and obviously all the different countries around the world. Basically, different countries have different numbers for 911. We call it 911 being North American oriented, but in Europe it's 112, and in some parts of the world they have, for example, 3 different numbers depending on whether you're calling police, fire, and ambulance, and so on. So with that, the final destination of a 911 call, it goes to this thing called a PSAP, which is a public safety answering point. And the whole idea is someone places a call and routing that call to the right PSAP operator, because it's not a centralized dispatching, it's more in a regional, local kind of jurisdiction. And so there's no federal mandate in the United States or in Canada that says that the government's funding these PSAPs and they follow federal laws. In fact, it's actually done on the city or county boundaries. They're mandated, each city and county, to deliver a PSAP, but the funding is done at the city-county level. And basically, so that's actually important to understand, that different PSAPs have different evolutions on what they're supporting. The other thing is that, in the 70s, initially 911 was just be able to route to the right PSAP operator. But in the 70s, the idea, the federal mandate was to actually include location information. And that turned into E911 and enhanced 911. And basically with that comes not only the calling number, which we call the automatic number identifier of the calling party, but also the location, which we call the alley, and we'll see this in the diagram coming up, what we call a database that the number can look up, and also route to the right PSAP, and also use that to actually give the location information of the calling party. All databases are provisioned ahead of time, and so you'll see that in the diagram coming up. It's a process of, when a company rolls out 911, how they have to provision that database. Strong regulations in many parts of the world, as I talked about, but generally it doesn't apply to enterprises. In North America, I talked about 911 in a way of regulations that must have E911. Service providers must apply it, homes get it. But basically for the enterprises, it depends on the state you're in some places even the county. Generally just that you can do a 911 call and get to the building. In some states is sufficient, but in other states you must have, and they've imposed regulatory kind of mandates for enterprises. Sometimes it has to do with the number of employees, the square footage of the place, and so on. And so this then applies to how do you handle those kind of regulatory requirements that are different per state and county. So sometimes the companies also deploy 911 that's more granular, that has to do with goodwill or just their own policies and to mitigate against civil lawsuits. So sometimes that's the motivation for that. In all cases, Lync 2010 has the capability to meet these requirements. And as you'll see, AudioCodes has delivered a very elegant product on the E911 gateway to really solve a lot of the issues that I'm going to talk about. So fundamental to either the NG911 or the E911 911 models that Lync supports is the idea that there is this thing called a location information service. We call it the LIS. And the whole idea of the LIS is basically to provide location. Now we'll talk about how that's used, and I'll give you an example in this diagram right here. So obviously a client, a Lync client, is connected either wired or wireless to an AP wireless or wired to a switch, and that switch has a location with it, including could be right to the office number if it's wired. So what has to happen then initially is the administrator provisions inside Lync in our list a map of the network elements, which we call a wire map, that talks about for this switch, this port, here's the location. It could be this menu or the office number, or with this AP, here's the address and here's the floor it's on. So when a wireless device of Lync gets close to that AP and associates with it, they can get the address. The next thing happens when the address is put in by the administrator. It goes out to and validates this address against this thing called a master street address guide. And this emergency provider in the cloud will actually validate the address so that, if there's a typo or something that's not correct in the address, it can be validated so that when we finally do a 911 call, they're not dispatched to an address that's not valid. So that's the whole idea of the MSAG. It's just validate that the address is accurate. The next thing happens is the client boots up, and when it does, it sends a location request to the list, which is there's a way of discovering the list. And in that location request, there's a pecking order that he'll use, the device will use, to try to figure out its location. It will start with the LLDP, it'll start with the VSS ID of the WAP, that if it's using wireless, and if it's not, then it'll try to see if there's an LLDP information from the switch, and if that's not available, it'll give it subnet and then the MAC address. And so based upon that, the list actually tries to figure out, in that pecking order, which one it has a location for. When it finally gives a location and finds the location, it gives that back to the client. And now the client has its location information. And this is critical, both the E911 model I'm going to talk about and the NG911 model. This will be now put into what we call a PIDA-flow object in the invite message. And that location is now going to be used throughout the two models to figure out location and routing to the right PSAP operator. Something to realize that if for some reason that there is no address in the list and it's required to have an address, then at that point the link will prompt the user to put an address in. And that address can be further validated against the MSAG, or it cannot. In the case when it's not validated, we will know that there's a non-validated flag in the invite on the PIDA-flow object, and that non-validated flag will mean that it will have to route to a default PSAP operator to then manually take the call and say, we see this is your address, is this correct? If they answer yes, then that default PSAP operator will then route it to the actual PSAP, knowing that the address is being validated by that default PSAP operator. So that's how the whole thing works, and now we'll see how it applies to different models. So the first model I'm going to talk about is this E911 gateway model, which is what AudioCodes implements, and has done a phenomenal job of implementing it. And I'll talk about that in detail. Traditionally, the E911 that you get now from your voice provider is well established. It's been done throughout the, since the 80s, 90s, and so on. It's based on a TDM infrastructure, on the PSTN, SS7 kind of TDM infrastructure. Every LEC, local exchange carrier in the country, has traditional 911 services. It's based on the concept of an ANI, and I talked about this automatic number identifier. And this ANI is now going to be mapped to a calling party called an ELIN. It's the same thing. When we say ANI or ELIN, think it's the same concept, except ELIN's used inside the enterprise as a label versus ANI's used inside the service, the TDM provider, emergency provider. And then again, the ALI is the same thing. The ALI and the URL is the same thing. And again, the ELIN is called the emergency location identification number. Then that relates to the ANI, and the URL is really called the emergency response location, which is the same label as the ALI. You'll see that in the diagrams coming up. All databases are provisioned ahead of time. I'll talk about this. Multi-line telephone systems uses the TDM interfaces today, and I'll show you a diagram of it. And it's well understood how to do this. Everybody does this. It's been going on for decades. The ELIN gateway value is it can take existing customers who are deployed VoIP, who's using Cisco and Avaya and wants to turn up a link. They can not have to go to a whole new paradigm of NG911. Also, ELIN gives the ability for users to move within an enterprise, and they'll be mapped to a security zone based upon where they are, and that security zone maps to an ELIN number, which then gives location information. So if you think about it, and you'll see this in the diagrams, an ELIN is kind of like a multiplexing of a bunch of users in a certain zone into one number, which represents a floor of that location or some kind of zone. There's good reasons to do that. If you don't need nomadic outside of the enterprises, which is what NG911 would give you, or you want to use your traditional TDM network because you can't get NG911 services in certain parts of the world. And some enterprises just want to use it because they bought a gateway-like audio codes, and they get this for kind of a small value or for free included in that offering. So today's multi-line telephone systems, how they've been currently doing this, and this could be for just a regular just regular telephony system, not necessarily IP-based, that the phone extension gets normally a DID line, and that DID line is used as the ELIN number or the ANI, and that ELIN number is bought from typically 5 to 25 cents per number from the local exchange carrier, and they normally use kind of like a PSTN kind of trunk, BRI, PRI kind of trunk, anyways, so that trunk maps to the TDM network, the PSTN network of the LEC, and you see the TAM switch. And then they have these selective routers that when there's a 911 call, it goes to selective routers. The selective routers look at the calling party, the ANI or the ELIN, and then looks to their database and figure out what's the right PSAP dot to route that through, and then the call goes through that. When the call goes to the PSAP operator then has the ability through their display to go look at the ALI database and look at from the calling number that ALI database is indexed, and they get the location. To do all of this, the ALI database is run by the local exchange carrier, and the local exchange carrier does not allow anybody to just populate that. So there has to be this front end where the user can populate their information, which is called the PS ALI database. It's run by the LEC, or run by different other organizations. And it's really a portal for the user, for the administrator to put in the location information for that enterprise, including floor numbers and more detailed information. And then that gets put in for a dynamic process by the administrator, and then that database is uploaded in the ALI database, checked for validations and so on some process of every week, couple of weeks, or every month or so on. So that's really how things work today in the ELIN model. And I'll show you how this now applies to audio codes and to VoIP itself. So in the audio codes implementation of ELIN, and traditionally anybody's ELIN gateway model, what happens is the link client obviously is associated to a switch or AP that has location. That location information is stored in what we call and gets back its information and stored in a PIDFlow object that gets sent out in the invite. So as you see here in the diagram, when an E911 call happens, it gets routed to the list, routed to the link servers, and the mediation server then routes it to the gateway. The gateway sees this PIDFlow object, and inside the PIDFlow object, there's an actual, in the way the audio codes implement, is the ELIN number, or a set of numbers. The gateway will take the ELIN number and then say, oh, okay, you belong to this zone, because you've given, it's determined the ELIN number from the list. And then that ELIN is used and placed out as the calling number for the 911 call. Again, the process works the same as I described before. It gets routed to the right PSAP. The PSAP looks at the ELIN, goes to the ALI database, and pops out the location information. So what this really allows, and you'll see this in the next diagram, is this multiplexing effect. And basically what happens is you take a certain building or areas, and you kind of carve them out into zones. And when a user moves, a link user moves into a zone, the list will be queried again because they will change connections, unplug into Ethernet, or move to a different AP, and that will query the list. The list will say, oh, you're now in this AP or in this switch, and that maps to this ELIN number because the admin had populated the ELIN numbers inside the list. That ELIN number then is used inside the gateway. The gateway then uses up the ELIN number and then again places out like I described before. So this is a very simple process. It's a way of multiplexing a bunch of users into one ELIN number, so you pay one price for that ELIN number, like say 25 cents, but you get a whole bunch of users mapped to that because it represents a zone. Very powerful model, very economical, and really used in a lot of great deployments. When to do this ELIN model versus the NG911 model has to do with the customer profile. The key takeaways here is if a customer is basically running in more like a campus environment, have maybe 50,000 users, like in Microsoft we have about 50,000 in the Redmond area, or Boeing, or you look at the University of Washington. We're mainly in an area where we only have 1 or 2 PSAPs that we can kind of route to. And so because of that, we only pay for 1 PSLE database. And that's only around $300 to $500 a month. And so therefore, this is a perfect mapping, because in the ELIN model, we're sharing 1 ELIN number with a whole set of bunch of users in that zone. And so it's very economical. And there's some numbers that Alan will show you how economical that is for deploying 911. Compared to the NG911 model, where they charge you per user, which can be very expensive, but gives you other values. So the other main point about the ELIN gateway model is that it allows you to actually basically give you the ability to roam within an enterprise, but not outside the enterprise. Because if you roam outside the enterprise to your home or to the public hotspots, you'd have to have a ELIN number for that, and that kind of defeats the purpose. So it's really geared for mobility within the enterprise or nomadic movements within the enterprises of the campus. You can get the right location of the user to a zone-based, and then you're only paying for 1 PSLE database because you represent a geographical area that's pretty well in one part of the country. How it works today is that PSLE databases are different, and you have to pay for each one if you're in different parts of the country, and so that can be expensive. And at that point, you might want to go to the NG911 model, which I'll talk about in a second. So that's the ELIN gateway model. If you have any questions, please start teeing them up in the Q&A, and we'll answer that right after the presentations here. The next model I'm going to talk about is the NG911 model, and Lync supports this too. And the NG911 model is really based upon some really good, innovative, future-thinking use cases and scenarios. One of them is users want to be able to text. People want to use video and so on. Obviously, the smartphones all have this capability, and certainly, Lync is moving more and more as a UC application on the smartphones and using Wi-Fi and so on to get there. It also uses a SIP and IP connectivity instead of SS7 and TDM. This is a key point, that the NG911 is a model of end-to-end using SIP and IP, and that's the full vision of NG911. I'll talk about what we'll do to accommodate this kind of vision. It's a centralized PSAP routing model. So what this means is, you'll see this in the next diagram, there's a centralized kind of what we call a voice positioning center that's somewhere in the country. And no matter where you go in the country, anywhere in the United States, and sometimes even in Canada to get to North America, you can actually be anywhere in North America or the States, and it'll route to the centralized VPC, and the VPC will then route to any of the PSAPs in the country, and you don't need a PSLE database like you had to do with the ELIN model. It's all very kind of innovative and very kind of centralized model. Mobility within the enterprise is obviously supported just like the ELIN model, but more importantly, users can be anywhere mobile, anywhere in the country, and still get routed correctly and give the right location information. It potentials for lower capital costs if you have a typical deployment that has multiple campuses or large buildings throughout the country, would have to pay for multiple PSLE databases, and that could be more expensive than paying per user and this whole other extra feature of being mobile anywhere. So there's pros and cons. It has to do with the profile of what you're trying to solve with your customer. The Lync 2010 supports this NG911 model, and it's really NG911 capable, compatible, and today no one really has deployed a full NG911 from the user all the way to the PSAP operators. And the reason is, you'll see this in my diagram coming up, the PSAP operators don't have the ability today of supporting SIP and IP right directly into their PSAPs. They still have this TDM mentality and have not been upgraded. A lot of this has to do with funding. Some states actually has funded this initiative to this end-to-end NG911 model, which we call the NINA is a standard for North America for defining this, and it's called the I3 model. We're actually going to show you the I2 model, which is like the precursor of the end-to-end NG911. It actually, like I said, talked about dynamic capabilities within the enterprise and outside. It allows, obviously, moves as and changes almost instantly. There's no concept of having to program a PSLE database with location like the TDM model, and it's all done in the invite message from the list. It's sent all the way through the end to the PSAP operator. You'll see that in a second. And the key part also, it's a really great model if you're using centralized SIP trunking. This actually happens where sometimes in the SIP trunking bundle, you get this NG911 capability service built into it. And we have some providers that actually now are partners that do this. So in the NG911 model, we'll start. This looks like a complex diagram. You'll see on the left is this voice positioning center. And the enterprise has to connect to this voice positioning center and to this PSAP gateway network and so on. Normally either with dedicated circuits, which can be very expensive, or more people are using just private peering or the internet to get to the voice positioning center. And what happens here, and I'll take you through an animation, is the device, Lync client device, is connected to a switch in this example, and it's learned it's through the list exchange I went through, it learned its location. That location gets put into a PIDFlow object in the invite message. That then gets routed through from our list to the mediation server up to the voice positioning center. And at this point, the call routing server inside the voice positioning center looks up the PIDFlow object and the calling number, well, the PIDFlow object actually, and then looks and puts that into the emergency routing database on the top right. You see there that database. That database then, so first of all, it has to look at the right PSAP to route through, so it gets that in the call routing server, and then pops into the location in the PIDFlow object into this emergency routing database and creates what they call a pseudo ANI. And the pseudo ANI now is sent out to the PSAP gateway, to the right gateway that goes to the right PSAP operator. This gateway's only function is to convert from IP to TDM, and each gateway handles a selective amount of PSAP operators. The call continues now, but it continues in a TDM model from IP to TDM, or SS7, and then gets to the PSAP operator. The PSAP operator sees this PANI record, which is really a shell record that points to the database. Let me see. Oh, sorry. Then media starts up before the location actually starts, so that they can start talking. And then the operator's terminal will actually start querying the ALI database for the location. And in the ALI database, this PANI is a shell record, which the ALI database knows that it's a shell record that points back to the voice positioning center. And the voice positioning center now pops that initial push that it did on the location that reference to the PANI as the index, and then locations given back to the operator. So it's a much more advanced model. It allows centralized services to find location of the user, but obviously the user must provide location through this list service within the enterprise, and that's what Lync does. So that's really the NG911 model, and both the ELIN or NG911 has a feature in Lync where we automatically do an IM to security desk, and some ELIN gateways and or NG911 service providers will actually bridge in the security party so that there's a three-way conference call going on. So optimal customer profile for NG911 is key thing. I want to be able to have my users go anywhere in the country and get 911 and get their location. The other one is they might have sites all over the country. They're bigger sites that need to have, location by not just by the building, but by the actual zone or by floor or so on, or even by office. And so instead of paying multiple PSLE database charges, because they might be 10 charges of $500, they'd rather pay it as a per user basis, and that's normally how this NG911 service works, per user basis. And so it gives them that extra feature of mobility anywhere in the country, and it's somehow maps out to a cheaper cost than paying the PSLE databases per month. And so it all has to do with the number of users and so on. And so that's the key aspects of what this model and profile is all about. So with that, I have to read you the disclaimer again. So please read that, and I want to thank you for letting me speak on this, and I'll hand this back over to Alan.
Great, wonderful. Thank you very much, Pascal. And I think you did a great job detailing what is a pretty complex, pretty technical situation or scenario that would happen, and I think gave some great insight. And now that I've seen it a couple times, I think I understand it even too. So,
Well, I'll be here at NG Call. So
yeah, exactly. So next, I'm going to turn it over to Chris Sheridan. Chris has brought a great customer case study, and so Chris, take it from here.
Excellent. Thank you very much, Alan. So again, I'm Chris Sheridan. I am a VTSP, that's a Virtual Technology Solutions Partner for Microsoft, and a Solutions Architect for Sentry. Sentry is a Microsoft partner. We're actually Partner of the Year 2 years running. We specialize actually in the entire Microsoft suite. So what makes us different is that we actually look at the holistic view of your entire environment. While we're focused here today on Lync, we also have to think about how it touches the rest of your environment. So today, in looking at Lync and how to do E911, we wanted to bring forth a great customer we had who did a white paper article with Microsoft recently, and it's a higher education institution based here in Boston. About 1,000 users for faculty and staff, so it was a smaller college based in downtown, so it covered about a 5-block area in Boston. The incumbent was Avaya, and they were replacing Avaya with Lync and going through that migration, and really needed to figure out how they were going to deal with E911 and security on campus. So a lot of their requirements went around their public safety group and wanting to make sure they stayed in the loop on all calls to 911 on campus. But because the campus was spread out in multiple buildings in that urban area, they really needed to be able to make sure they could get information out correctly. And so with all that, what we ended up doing was installing the audio codes gateways and the FXS and FXO gateways, because they had another unique requirement in that they had these police call boxes around campus that needed to be able to be up and running in case of an emergency, so there were analog devices, and they needed to be able to make sure that they could route their internal campus security there as fast as possible, no matter, regardless of where it was on campus. So we had to bring all of those back into a centralized location through an analog gateway and then into the system, and then enabled security desk integration so that we could do that instant message pop-up for the security group so that they could be made aware and react accordingly. So again, when you look at these universities, they're great cases for the security desk and the audio codes, because you have your own internal security. And I was talking to between doing the webinar on Tuesday and today, I was talking to a customer, and even just doing this webinar got my mind thinking, what about the security desk at a building? And even if it's a multi-tenant building, wouldn't you want the security at the front desk to be made aware of what was going on? So I actually now have another customer who's looking to work with their outsourced security company in the managed building to give them access to their Lync environment so that they can pop an IM when they call 911, and that they can make use of their system. So it's a really great system in that it's flexible and meets the needs of these campus-based areas. I think Pascal did a great job identifying that customer type that this really applies to. So, through a simple solution that was very cost-effective, we were able to meet all of their security requirements and really help keep them moving forward with their project. It's a really great customer and how they deployed it. If there are any questions on that, feel free to post in the Q&A, and with that, I'll turn it back over to Alan.
Great, thank you very much, Chris. And I think it really that's a good example of I think it's a really good fit example, as you mentioned, the university environment, especially with all the call boxes, especially with some of the concerns recently in campus security. Right. So let's move on then to some of the solutions that Audio Codes has brought to the table, and we wanted to start and share a little bit of information. Is that Microsoft on their TechNet certification program and on their website maintains a list of certified gateways for E911 services. And if you chase that link that I put there, or if you know the TechNet environment and look at the E911 environment, you'll discover that there's only one gateway that has a full enhanced gateway with E-Lync capabilities, and of course that's audio codes. This is something we've strategically recognized quite some time ago with a collaboration with Microsoft and implemented over this last year, and we're actually demonstrating this next week at the Enterprise Connect event. And where the gateway would fit in is like any other enhanced gateway. It sits in between the mediation server and the link pool, and of course the public switch telephone network, either through T1s or E1s, PRIs, and are able to make and receive regular telephone calls through that gateway. And in a situation where a 911 call occurs on the link server, the gateway steps in to this E-Lyn mode that we've mentioned before. And the basic process that Pascal explains so well, just to sort of reinforce that, is based on this emergency location identification number. This is, typically one number is assigned to each zone within a building. In this particular example here, we've got 3 floors. Each one would get its own E-Lyn, and other facilities like branch offices would have their own separate numbers too. And of course, those the addresses or location information would be added into that alley database. What happens in the situation that somebody dials 911? Of course, the call then goes through the link environment, through the gateway, eventually through the PSTN to the PSAP, passing along that PIDA flow information that was described earlier. A couple of interesting things about our implementation of the E911 environment. First of all, our gateway does recognize the fact that somebody makes a 911 or any other number based on the region in the globe that can be pre-configured when a call is captured in substituting the E-Lyn number for the PSAP. But it also does a couple of other important things. First of all, it actually retains the header of the call, and what that's done for is in the case that a caller who dials 911 is prematurely disconnected, either inadvertently hangs up before he delivers all the information to the 911 center, or some interruption in communications, the PSAP operator can do a return call, and when that return call arrives back to the gateway, it'll have the E-Lyn number in the call in a PRI setup message. And what the gateway then does is it looks at its little internal database from the last 60 minutes and can do a reverse mapping and send that call back to the person who initiated the 911 call, allowing it to be reestablished. And this is, of course, important for those some of the regulatory compliance environments. In addition to that, too, the gateway also has the capability to kick off a call that might arrive. Let's say a call arrives at a gateway and the gateway is fully occupied. What can happen in that situation is that when a call arrives, the gateway looks at the its current usage. If all the ports are in use, it'll actually randomly select a port, disconnect one of those calls, force disconnect it, and then take that port over to initiate the 911 call. And it can do that a number of times simultaneously. And typically, earthquakes, fires, things like that, more than one person would call 911, and of course all those calls need to be routed to the 911 PSAP. So that preemption feature is also a facet as part of the gateway. As Pascal hinted, I also wanted to spend a moment talk about some of the financial implications. And this is the example we got here is a little bit of an extreme example, but it hopefully gives you the some understanding of how it works. But in a nutshell, if someone were to use the NG911 or not to use this consolidation or regionalization with E-Lyn numbers, and they've registered every single one of their ANI numbers, and let's say there's 1,000 seats in a particular building, you registered all 1,000 numbers, and you got it right down to the office number. If you tallied up all the charges for the state taxes and county taxes and the fees that go with it for the 1,000 lines, it's very easy to get to somewhere around $9,000 a year just to have all those telephone numbers registered with the PSAP using the NG or the other mechanism. By using the E-Lyn consolidation on the right-hand side, if we take that entire facility and map it to just one single E-Lyn number, and then use the security desk to direct people to the individual space that might have the emergency, You only have to register one number, and that one number, at its 75 cents, might cost you $9 a year. So there's a savings there of, some $8,991 per year by doing the mapping between the individual DIDs and an ELIN number. And of course, this, significant cost savings needs to be considered in a network design as you go forward. So a question that pops up often is, what are the devices that support this functionality from audio codes? And it's the range of our digital gateways from our smallest little median 800 on the right with a single T1 or E1 span up to the median 1000 up to 4 spans, the 2000 up to 16 T1 or E1 spans, the immediate 3000 with its N+1 redundancy, supporting 3 DS3s. So a very, very broad range of our digital gateways that support this functionality. In addition to that, too, we also offer it in our survivable branch appliances, which is the median 800, median 1000, SBAs that are common in those remote branch office deployments, and of course our enterprise session border controllers, which act as a hybrid, either supporting SIP trunks or TDM trunks simultaneously, can leverage that. I also want to point out too here, we've got it on the slide here, we've got some really good resources, and specific to the ELIN Gateway Configuration Guide on our website. If you're registered on our website, you can access this document. Fastest way to probably get to it is just type ELIN Gateway into the little search box on our website. It'll take you right to the document. It gives you an exhaustive, detailed look at not only some of the material we've covered today in a technical perspective, but also how to properly configure everything.
Another excellent presentation.
Yes, yeah, very good. E911, of course, is very important, as you just learned. Yeah.
Without a doubt. So what can we look forward to in the next session?
So next we're going to start to talk about moving off the PBX. And this is the process of initially integrating Microsoft Lync to an existing PBX, but then starting to move to a standalone environment that's Lync only. So it's a big step for a lot of businesses, and we talk about some of the challenges and some of the hurdles involved.
A big step indeed, so be sure to check that out.
Yep.